Hi there everybody, we are now going to look at simplifying surds. Alright, so if you're not sure what a surd is essentially a square root of a number, and a square root of a number which does not give a whole number. Alright, so surd is an irrational number left as a square root. Okay, that's how it's termed. So to simplify surds, you need to look at whether or not there is a square number that is a factor of it. So let me give you an example. So if I looked at what it says today, simplifying the square root of 12, alright, well what square number factor goes into 12? Well, hopefully you know your factors, and we've done it recently. Hopefully you've done it recently. Is 4 is a factor of 12, and 4 is a square number. All right, so I'm going to rewrite square root of 12 to the square root of 4 times 3. All right, but I can square root 4. Well, if I can square root 4, I know the square root of 4 is 2, so that comes outside, or I switch it in terms of I separate it out. So square root of 4 times square root of 3. But like I was about to say, is I know that I can square root the 4. When I square root the 4, it actually becomes 2. So 2 comes outside the square root, essentially, and I'm going to put them together because I can't square root 3, and that's going to give me my simplification. All right, so what you're looking for is a square number, all right, that goes into it, so a factor of it, and then you are literally going to square root that number because you can, and then you're going to tag it on front of whatever is left inside. All right, and it's really important you get the biggest square number that goes in there as opposed to just any square number. All right, so here I've got 3 root 18. All right, so I'm looking at the 18. Well, 18 is 9 times 2. So when I square root the 9, it becomes the square root of 9 outside. So therefore, that's going to be 3. Okay, so 3. And then I'm left with the root 2. But I started this original kind of question with another 3 outside. So that means I need to do 3 times the 3, which is going to give you 9 root 2, essentially. All right, so we ain't got round to it here. So that's 3 root 2 for that particular bit. And remember, I'm timesing it by 3, so I've got 9 root 2 at the end. All right, because I had 3 times root 18, which is 3 times 3 root 2, we got from here. And then obviously I times the whole numbers together to give you 9 root 12. All right. So adding and subtracting surds, well, as long as the surd inside is the same, then we can do it. But it's based purely on the number that's outside. All right. So if you assume root 7 is just a random number or a random letter, then what we're saying here, so let's assume it's an x. It was like 4x plus 5x. Well, that would be 9x. Well, that's exactly what you do. You do 9 root 7. It's like 4 of something and 5 of something is 9 of something. Because you don't really know what the something is. You don't know what root 7 is, so we don't bother. All right. But to clarify, if you're doing a root 7 plus root 3, this does not work. All right, this does not work. Again, because we don't really know what root 7 is, and we don't really know what root 3 is, but it certainly is not root 10. Okay, you can, by all means, you can try it with a calculator. I promise you, this is not the same thing. We can only bring together surds if the surds are both the same. All right, so sometimes you need to simplify the surd to get the same root. So maybe something like this. So what I was saying is root 75 minus root 12, I can't do. But I can simplify the pair of them. So root 12 is root 4 over root 4 times 3. So that's going to give you 2 root 3. So if I know that's going to be the case, then really I'm hoping that I've got something times 3 in here, which is 25 times 3. And of course I've got another square number. So when I take that out, it's going to be 5 root 3. And now I can do the 5 root 3, take away the 2 root 3, which is going to give me 3 root 3 as my final solution. Okay. All right. Last one, I think, in terms of multiplying surds. Right, so if you're multiplying surds, then the numbers out under the root together multiply. And then obviously the numbers on the outside multiply. So let's have a look. All right, so root 7 times root 3, not to overcomplicate this at all, that's root 21. If you've got root 8 times root 12, well, that's going to be root 16. I can square root 16 though, so that's going to be 4. If you've got, like I said, numbers on the outside and numbers on the inside, then you do the numbers on the outside. So for example, this first one, I'm going to do 2 times 3. All right, it's going to give me 6. And then I'm going to do root 5 times root 7, which is going to be root 35. So it should be 6 root 35. And you are looking to see whether or not it simplifies or does anything, but it doesn't. And then over here, well, we've already seen something similar to this. All right, well, now I could do 12 times 75. that's going to be very difficult to do in my head. So if I can move these to simplified versions, which we had a minute ago. So if you remember, this one here, when I took the 4 out, was 2 root 3. And over here, when I took the 25 out, that was 5 root 3, I think. So here we go. That makes it a little bit easier. So when we do the 2 times the 5, it gives you 10. And then you've got root 3 times root 3, which is root 9, which square root of 9 is 3. So you're going to have 10 times 3, essentially. All right, there you go. So 10 root 9 is 10 times 3, which is going to give you 30. That's quite a nice one. All right, so that is surds, essentially. So a few rules of surds for you to kind of apply. We haven't mentioned divide, so I might as well mention it while we're here, but the method's very much the same. When you do divide, you treat the numbers as you would do, you treat the surds as you would do. And of course, the only difficulty arises if you cannot divide the surds, but then you're just going to leave it as a fraction in relation to surds. All right, but let's hope you don't get much of that. All right, so there are some questions online on maths-school.co.uk. Link is at the bottom as normal. All right, thanks for listening.